Think Tokyo, the most populous city in the world, with over 37 million inhabitants. But if you roam the streets of the so-called world of lights, you'll notice that the streets are not filled with thousands of wrappers, bottles, and plastic bags. Trash collection is really well organized. Obviously, this isn't a novel concept to many. Garbage trucks have become a staple of public sanitation. These huge green trucks are known for their piercing beeps as trash is loaded onto their docks. They are like night crawlers snaking in and out of alleys and collecting our trash. But while these trucks are so crucial to all of our communities, are they really the best our federal waste services can do? Well, in December of 2021, as part of my routine outreach role with Sierra Club, a US based environmental organization, I happened to interview a politician who told me about how the carbon footprint of large vehicles is oddly neglected. So, as it happened, when the garbage truck came rolling in for a pleasant 6:30 a.m. wake up on Wednesday, I thought I'd look into the carbon emissions of garbage trucks. Weird, right? That's what I thought. But as it turns out, the average garbage truck emits 1,045 grams per kilometer of carbon, and an average of four such trucks are deployed into each autonomous region. That's each autonomous region, not even each city. So I knew I wanted to change this. Hi, my name is Khym from the United States, and my research project is titled Sustainable Trash Collecting Method based on collective travel planning and maximum coverage problem. The collective travel planning query is a system present in collective travel systems such as Uber. It assigns multiple users to one vehicle point, and they travel together to a destination nearby all individual destinations. Currently, garbage trucks travel through each and every alley or street. In response, I assigned a meeting point for a truck to stop. From there on, sanitation workers would pick up garbage to and from the assigned meeting points by walking. Here we have the project's baseline function below, used for testing. X is the cost for the workers who bring trash back and forth between the query points, which are the trash sites, and meeting points. Meanwhile, Y is the cost of truck emissions, and the distance dis is doubled. These trash is idle, and the sanitation workers must travel two ways from their original locations. The maximum coverage problem addresses the limitations to ranges of distances people at meeting points can move about to reach various query points. Typically, the concept moves spatial ranges based on points included in workers' mobility range from meeting points. I weighted the coverage problem so that the ranges would move where the trash weight is heaviest. That way, sanitation workers will travel the least from their trucks to collect trash from sites with a lot of accumulated waste. I then assigned an EM variable, which chooses the best candidates to be meeting points, otherwise stop points for trucks. As displayed on the screen, we see that in a simulation with three stops, the chosen meeting points are the three with arrows as they are the heaviest. These heavy points could be schools or offices. I computed these changes as my novel WMCCT spatial network, otherwise weighted maximum coverage problem collective travel. In a Python simulation, and the environmental cost, carbon footprint, as well as computational time complexity were all much more efficient than the current waste collection procedure. So with the success of multiple tests, I wanted to bring this project as close to reality as possible, but there were no existing platforms to record trash or any relevant information. So I developed a prototype as an app where users can one, report the quantity of trash they have, and two, note locations on a map embedded in the app where they believe it would be for the common good to place trash cans. Using my project and app, new environmental policy can be implemented with modeling and computing for more sustainable sanitation practices. Thank you for watching the video.